All right, so this is going to go over the first part of the notes for the work, power, and energy unit. We're going to focus on just work and power at this point. So first off, what is work? Work is the transfer of energy when a force makes an object move. In order for something to be considered work, there's two criteria that must be met. First, the force that's applied must make the object move. And more importantly, the movement must be in the same direction as the force. So in our examples over here, when the person is pushing the box, so they're pushing to the right and the box is moving to the right, then yes, that would be considered work. If a person is lifting a bag of groceries, so the force is going upwards because they're lifting and the bag moves up, that is also considered work. However, in a situation where someone is carrying something, the force is being used, the force that's holding the object is going to be in an upward direction, but walking is in the horizontal direction. So that technically is not considered work on the object. That doesn't mean that the person themselves is not doing work on themselves, right? They are using their body to move to the right and they are physically moving to the right. So their body is doing work. However, no work is being done on the object that they are carrying. So if we went through these examples, a person pushing on a wall, that would not be considered work because they would not be able to move the wall. So no matter how much force they used, if the wall did not move, it would not be considered work. A book falling to the ground, that would be considered work. It's not a person that's doing the work on the book. However, gravity is pulling the book down and the book falls downwards. So therefore, because the force and the movement are in the same direction, that would be considered work. A waiter carrying a tray, not work, again, because while they are holding it up, they're moving horizontal, so they're not in the same direction. And then finally, a rocket accelerating, through space would be considered work because the force of the rocket is pushing it through space. So that the force and the movement are in the same direction. The equation for work is force times distance. Notice it is distance, not displacement. Okay, so we don't care about direction in this case when we're determining how much work has been completed. So we have the force applied times the distance that's moved. Here we've got our little triangle here. And then the unit for work is the joule, Joule. Now, we don't want to confuse this with impulse. Impulse is a variable that is used in equations. Joule is a unit that comes after a number. So you're only going to see joule, the capital J, after an actual value, a numerical value. Okay, so that's work. That leads us into power. Power is a measure of how quickly the work is done. So the equation for power is power equals work divided by time. And here is our triangle here. The unit of power is what we call the watts. Think about a light bulb. If you have a 60-watt bulb, that's telling you the power of that light bulb, how bright it is going to be. So again, it's how much work you can complete over the period of time will determine your power. And again, don't get confused. Capital W is work when it's the variable, but when it's after a number, it's actually the watt. So if we looked at this little equation here, say you're lifting a puppy off the ground, it requires 50 joules of work. If it takes you 2.5 seconds to lift it, how much power have you used? Well, we have our variables. Power is what we are trying to solve for. Work is 50 joules, and time is 2.5 seconds. So if we plug that into our equation, we would have 50 divided by 2.5, which gives us a power of 20 watts. So that is the unit or the section on work and power. The next video will be about energy.